Hello, this is Paul, and today I will show you the solutions and the walkthrough through the day 4 of Advance of Code. So this problem is a bit, I don't know, I wouldn't call it a big problem. It's more of understanding what to do, and it's pretty simple, probably the same way simple as day 1. The only thing that you need is the computing power, or if your programming language that you use doesn't have the hashing functions, then it's a bit more difficult, but in general it's not that difficult to look up how MD5 hash works. But for this solution we'll just use an inbuilt library for that, and it's pretty good, I think. Okay, so let's start with what we have here. So let's close the previous solution. Alright, so for this specific problem set, we don't have an input set, which is quite good. But let's be consistent, and I'm sorry, we have to look for right. Okay, so this problem is looking for a specific answer just to get start printing hashes. For a specific secret key we have to enter append numbers for it, and to see if the hash contains 5 zeros for the first problem, which means that we just need to iterate through all the hashes starting from 0 to, let's say, for this example, 609 of 4343, and see that it has 5 zeros in front of it. I mean, hashes in general are just like functions that are used for cryptography to or for like MD5 is not that strong anymore. It's mostly used for file checking. When you use some function and you get hexadecimal result for that, a string of hexadecimals, then you can compare if you downloaded the right file or not, because if the MD5 hash is the same, it means that the ones that were presented in the download sites, if the download site says we have a MD5 hash for this specific packet, and in the Linux community it's pretty common to double check it. I got a bit carried away, but let's start looking into the problem. My input is this string, so I'll just do it as a day4 file and save it, and that's it. Just to be consistent with the previous days, as I mentioned. So let's create a file. We'll call it a day4 part 1. Right. Yeah, and let's simply read the data day4 file and save the data as, let's just simply read it into a string. It's like a really short string. Just to be consistent, that's all I care about. Yes, and so we need to find out what kind of libraries are used for hashing MD5. So for my case, when I use Python, we have a library which is simply called MD5, but it's deprecated, so here let's use hashlib. So hashlib has an example of how to use MD5. So we set a variable to a hashlib MD5 object, we update the string, and we digest it. By digesting, it means that you get the resultant hash. For this example, it gets a hash which is not necessary. It's definitely not a hexadecimal result. It can become we can look it up on the console what the actual symbols look like. Oh yeah, sorry, it's a bit different because like it doesn't accept concrete symbols for that, but it means that it's not hexadecimal. It might just be like some. If you've seen the font Wingdings, it can look similarly because the computer fonts can just not understand specific values. But for this, we'll just use a hex digest function because the day4 asks for hexadecimal results, which is here. So let's start working on it. So beforehand, let's import the hash lib. And yeah, so let's calculate the hash. Let's call it MD5 hash. Okay, so okay, so I think that I just need to see if I need to start with at least 5 zeros. The input is some secret key. Lowest, no leading zeros. Okay, so it starts from 1. Okay, so let's call it just like a number. It starts with 1, and the hash is hash lib MD5. So it's the object that we'll use, and let's call it simply hash is MD5 hash updates. I think if we can use that way. We can use it in one line, it's probably even better. Let's just write data plus string number. We have to like cast it to a string because it's an integer already, and we want the hex digest for that, which is the MD5 hash for the specific string. And then we just simply we can do it a bit differently. So while MD5 hash digest, hex digest, first 5 values, isn't it? Yes, the first 5 values, so it's from 0 to 5, I believe it should be to 4, is not equal to simply 0, 0, 0, 0, 0, 5 zeros. We keep on changing the number, which is number is equal the same by incrementing it by 1, and we remake the MD5 hash. We can simply copy this line from this MD5 hash. So we remake this object and we set it to hex digest, and generally we're just able to simply print the number in the end, and this number should be the answer for our question. So let's see, Python day4. So it might look that's okay, so that's a bit difficult. It's not working instantly, but that's because the hashes are rather difficult to compute, and probably my solution isn't the best, but let's then just do a bit of a different solution for this. So let's say that, okay, so let's leave it that way and say that, solution is this number. So that's just like assigning, but apart from that, let's just print every number just to see that something's happening. Oh, and it should probably be a good idea just to double check if it's actually 5 symbols, but it should be. I mean, I could have just given infinite loop, because 4 symbols is definitely not the same. Okay. Just to be sure. Yes, so the problem is that I've taken 4 symbols, I need to take it 5. Good, so let's just put it to work, and the answer is 282749, which is the answer here, and it corresponds to the same thing. So yeah, I've just made a simple mistake by using a wrong range, but this can be debugged quite easily just to see if it's actually the range that I need, because the length must be 5, because it's 5 zeros in here. And like for simply seeing that it's not a big problem and that everything's working, we just print the number and start looking at it. So this is the part 1 that we've done, and let's go to the part 2, which is straightforward. We just need 6 zeros. Let's go to part 2, copy everything that we have, and for the only difference that we need is like change it to the range and add a 0, and let's run it. So as you can see, the answer is almost 10 billion. Oh, sorry, I accidentally ran the wrong part. So this means that it will definitely run a bit longer, but nevertheless the value should hit it quite fast, I suppose. Let me see. Yeah, so it's only 2 millions already, so maybe recreating the same object every time is not a good thing, but I haven't done any kind of benchmarks, and probably the thing that is happening, and we see that, I mean, it's like we can't really see in the sense of 4 symbols. It means that, let's say that's 10,000 operations, the hex digests really fast, but maybe if there were some optimizations, and probably I don't know, I mean there's many parameters that are responsible for the benchmarking results, but generally I think that this could be a problem, and to make it fast, we might just want to like use the same hashlib to read it, and use something like, I don't know, if there's a specific like I suppose there's no specific solution for this. It's just like update means that it increases the string by, I mean, appends substring to a string, which means that for this example it just has this string, and after this sentence there's this string added, which is in general this string. But like to reset the string, I cannot see what's in it. Okay, let's see how much. Okay, we're almost, I mean, 2/3 done. I mean, another solution might just be using a different library. The previous deprecated one maybe has a better solution, but I cannot guarantee that. I haven't, as I said, I haven't done any kind of benchmarks for that. I mean, if I use a different programming languages such as like C or C++, which have better optimized code. I mean, I'm just like assuming, but it might just be faster that way too. But in general, it's everything boils down to the calculation of hash. So for this problem, it's MD5 hash, and we just get to simply calculate every value for that. I won't walk through the hash itself, but I suppose that it's a pretty complicated hash for a for this type of problem, and I suppose that the ones that wrote this problem didn't really see that we should use that. Use an implementation by implementing ourselves rather than just import a library for that. So the answer is 9962624, which is the solution. Great. So we're done for this day, and